Okay, so good afternoon, everyone. Today we are going to continue on our RAG journey by looking at how we can easily put together RAG using JavaScript. So, of course, remember last Wednesday we did a RAG and um, we used Python and then we put it behind the fast API endpoint. So now we're going to use JavaScript, Node.js, and we're also going to put it behind a Node.js endpoint, right? With Express and all of the other things. Then we are going to use FAISS for vector store, right? Um, and then we're going to use semantic chunking. So one of the things that we found out last one that we did, we actually used a simplistic chunking with overlap. And we found that some words got split, so the context was lost. So this time around, we are going to do the same thing, but we'll use semantic chunking so that the documents will be split at meaningful boundaries, right? Paragraph boundaries and so on. Then we'll use Gemini as our LLM that will do the actual language, um, um, understanding and the prompt and then giving you a response. So we're going to use Express.js to handle the file upload, the chunking, and then the query endpoints. Now, FAISS actually is a Python, it's actually a Python thing, right? And then sentence transformers. Well, we would look for another embedding. I wanted to use sentence transformers, but there is no there's no Python implementation. So we will just use the API call, right, to call the Hugging Face endpoint and get the response. So that's kind of the summary of what we want to do. So we'll start. Let me create a new. So I'm going to do this using, um, I'm going to use, I'm going to make a new repo just like last time in my GitHub. So, and then I'm going to use code spaces as well. So in the other one, I did use code spaces. Code spaces is really good because it just allows me to code online, right? And it's very easy to integrate it into my GitHub already. So I don't need to worry about too many things. All right. So I'll start off by creating the new repo. So I'll call it AI for the RAG.js. So this time around, we use JavaScript. Okay. Okay, so we'll create a code space. I need to check the other code space and ensure that we are good. Hmm. Okay. Yeah. So yes, it will create a new README file. All right, so the folder structure will have a server.js, which is the Node.js server file, basically that we use it to launch the endpoint, the web server, basically. Then we will have um, FAISS. So FAISS is a Python file because FAISS is Python actually. So I will have to create embeddings. So you can see that FAISS actually works best with Python, but you can still use it, uh, with JavaScript. Of course, I'll create the .env. The .env is where we will put our secrets. Then I'm going to create an uploads folder. So the uploads folder, that's where we will store the files that we are uploading. And then we'll also have an index store. So when you're using FAISS, by the way, FAISS is not a database. FAISS is kind of a framework that allows you to do all of the things that you can do with a vector database, right? It's a framework that speeds up semantic search and all of the things that you can basically do that vector databases are good at, indexing based on vectors, semantic search based on vectors, and all of that. But it's not a database, so you still need to create a place where you will store the actual data, right? So that's this index store. So we start with that. Then we will, of course, install our dependencies. So what are the dependencies? For a traditional basic for a basic Express app, right? You need to install. I'm assuming there is npm. So let me even check first of all that there is npm. Okay. So I can also check my node version is 22. npm version. Okay. So now, so we install Express, Malta, Node Fetch, and .env. So remember, .env is what we use to bring in environment variables. So while that is going on, right? Okay, that's done. That was pretty quick. So now we will do on the Python side, we need to pip install the FAISS, right? So pip install FAISS CPU and NumPy. Okay. Okay. So now, so first of all is we have a whole bunch of setup that we need to do for Express and in the server.js. I'm just going to paste this here and then I'll explain the code. So we first of all have require .env and then you call config. So this sets up your .env setup. So your .env, whatever secrets that you put in .env will be seen by the code. Then we'll of course bring in Express. We'll bring in Malta. Malta is a library in Express that allows you to upload documents, multiple documents, multiple uploads at the same time, store them and manage them. Spawn sync will allow you to run a child process. So why we need the child process is because FAISS, like we said, runs on Python. So we are going to create this Python script to manage the FAISS database. So whenever we want to call out to it, we will use the child process basically to spawn synchronously, call it, and then take the results that come back from it. Fetch will allow us to do API calls to the endpoint, both for embedding and for the Gemini, right? Um, then this is file system, which allows us to manage files. Then path, which allows us to manipulate path names and all of that. So those are the imports. Then we just start with app. We create an app, Express app. Then um, app.use. So we link Express into our um, we link JSON into it. And then we create an upload handler using Motor, right? And the destination, that is the base path where we want to store our upload, is the uploads folder, which we have already created. So those are basic stuff that you will start off with. So we have Motor, destination is uploads, okay? Now, let's get our API keys. So there are two main keys we will get. Since we're using FAISS, we don't need a key for the vector database. We only need a key for the Hugging Face API because we are going to use Hugging Face sentence transformers for the embedding. And the sentence transformer class only exists in Python. So we're not going to use the sentence transformer SDK. Rather, we'll just directly call the Hugging Face API. Then, of course, Gemini. So Gemini has a JavaScript SDK, so we'll use that. Okay, so the first thing is we need to create the script that we'll use to manage a file. So we call that Python script, or we can just call it file script. Okay, so we're using the path join current directory embedding underscore FAISS So that's the file we want to call whenever we want to run FAISS. Of course, if we are doing this from Python, we wouldn't need to have to call the script externally. Whatever is in the script will be part of our Python code, and we'll just have it. So then this is the index directory, which is the where we are storing the data, right? Basically, this will make up the index of our vector database. Okay, so we create that index directory. Well, we don't create it yet. At this point, we are just setting the value, and then we'll now check if it doesn't exist. So if the index directory doesn't exist, then it's library. So if you want to use it outside of Python, you still need, yeah. So FAISS is it's a Python-based library. So if you really need to use it outside of Python, you still need to create um, a Python script, and then you call out to that Python script, right? From whatever language that you are using. Okay, so I'm going to show that that's part of what we will see here. Okay, so so far I've been trying to set up the server, which is going to run everything, right? So I've done all the imports and I've set up the keys, which we will pick up from the .m file, and then we've set up constants for the embedding path and the index directory. So now I'll create the index directory if it doesn't exist. So that will be the first thing, right? Um, so make dir sync is going to wait for it to finish before continuing. If you use just make dir, it will not wait for it to finish. So it's a very simple. Now, one of the things that we want to change here is we want to go to semantic chunking. So let's see how we do that. Um, Normally, you can just make sure you split at word boundaries. Okay, so that's a simplistic semantic chunking. Even though that's not perfect, right? Because you could have word boundaries that will end up with incomplete sentences, right? But yeah, let's use a simple sentence based semantic chunking. At least that's better, right, than what we had before. So to implement this, so for those who are not JavaScript people, um, take note of the process. It's not really about the language, like I said, but the method, the algorithm, right? So target words is like saying, okay, we want to. This is the target amount of words that we want to chunk into, right? So if you remember when we were doing the other one, where we did a simple chunking with overlap, we actually had the the word count, right? We just had word count, and then we had our token size, rather. We had token size, and then we had overlap size. So I think our tokenizer was not very good because, well, we've effectively cut in the middle of a word. So maybe that was the problem with how it was tokenized. So, but here we will do a simple checking percentage. So the target word is a target. It may not be exactly 150, but it will be around that region. So we specify the sentences that we want to do. First of all, we split by using space, right? Now, there is this regular expression that we are going to use. So what this regular expression does is it can go back, right? It can go forwards and until it finds this match. Um, so regular expressions are a very interesting topic, which I would encourage any programmer to take some good time, right, to study and understand regular expressions. They're very, very useful. It's what you use basically for um, is what you use for all kinds of text processing, right? So, well, who knows? Maybe these days LLMs would be the ones that will do all of this. But LLMs are too slow for, basic text processing like what we have now. So let me see if I can explain this. So a regular expression normally starts off with delimiters. So the first character in a regular expression is a delimiter, and we're using a slash at the beginning. We also need to use that same character at the end. So the slash at the beginning and the slash at the end are just like a container. Think of it like quotes, right? In regular expression, you use a slash. I think in JavaScript, it's even standardized. I use a slash. to represent a regular expression rather than the quotes. So that is just a container. Now, the next thing in this regular expression is you have this bracket and you have the closing bracket. So brackets are used for grouping matches, right? When a regular expression, first of all, is a way of expressing a pattern so that when you're searching in your text, anything that matches that pattern will be returned as a, part of the matches. It will be returned as a return value. So regular expressions are very good for you to use in um, text searches, right? They allow you to put lots of different kinds of patterns and wildcards. So you don't need to match some specific matches, but you can match generic, words or text. So that's the power of regular expressions. And it has a syntax. So in this case, like I said, the parentheses here are used for grouping. So this will group the first match, right? And then, so you have this sequence of three characters, the question mark, the less than sign, and the equals. So what this means in regular expression is what we call positive look behind. So there is what we call look ahead and there is look behind in regular expressions. So look ahead is always jump ahead. If you find a match in front, right, just go straight to that match. So look behind also means if I'm checking and I'm currently at it, because regular expressions basically do the matches by going sequentially through the text, character for character or character by character. So it gets to a certain character, it look behind sometimes can go back to see if if the match is preceded by something else, right? So that's what look behind means. So what it means is that only match if it is preceded by this, what is inside. So this third thing here is another sequence of characters. When you see square brackets in a regular expression, it means what we call a character class. So, well, that's regular expression terminology. So it means anything that is inside between this opening square bracket and there will be a corresponding closing square bracket. So anything between the opening square bracket and the corresponding closing square bracket, everything in there is considered as a match. You can actually type letters or numbers, or combinations of letters and numbers. But it's saying if what we are searching, if we are searching in a particular text and one of the characters in this list of things that are between the opening and closing square braces or brackets rather, if any of them is seen, then consider it as a match. So that's what we mean by character class. So now when you have these square brackets, right? Sorry, when you have this grouping, search grouping, this opening parentheses and closing parentheses and everything, and followed by this, it basically means this is a match, but not an actual match, but a condition for the match. So we are saying that for there to be a match, this condition must be fulfilled. So what is the condition? The condition is that what is in this place must be either a full stop, that's a dot, or an exclamation mark, or a question mark, right? If it's a full stop or an exclamation mark or a question mark, that's what the character class means. It must be either one of those three things. If it is any one of those three things, then this condition is true. So we are saying split when this condition is true. So it's not really a match. It's saying split when this condition is true. But in addition to that, we have this other one, which this backslash is what we call an escape character. So backslash S has a special meaning in regular expression, which is a white space. Basically, a white space is a character on a keyboard that represents a space, either an actual space or a new line or a tab character, any of those characters are not actually printed, but you will see them as a gap in your text, right? Those are called white space characters. So it will match a white space character. Then the plus means any number, sorry, not any number, it means one or more white space characters. So when you pull all of this together, this regular expression is basically saying only match a any number of white space characters where the white space character is preceded by a dot, an exclamation mark, or a question mark. And that is a condition that actually means that a sentence has ended, because a sentence has to end with either a dot, exclamation mark, question mark, and then after there has to be a white space, either a single space or tab or something. You know, if you have a dot and there's no space after, maybe a dot with another normal character, that's not the end of a sentence, because that happens especially in programming. So what this whole thing does is that it's able to detect sentence boundaries. That's what this that's the regular expression. So to convert this to interpret it in English, it means split the text that is passed in at a point where a sentence comes to an end, you know, and there's a space after that sentence, right? So that's the summary of that. Okay, so now that's a very good regular expression, well composed. So with that, right, you now have sentences being a list of all the sentences in that document that has been updated on in that text. Now, so we continue the chunking process. So first of all, we start with empty, and then so let me just bring this in so that it will be much faster. So we have we are initializing the current words, current chunk, and the current words. Then after that, we will run a loop. So the loop is going to go through each sentence, and so what it does is it will look through S, which is each sentence in the sentences that we have split, and then we will take the words, right? So again, this is another split. We split the sentence at white spaces. So white spaces are basically word boundaries, right? So in this case, we are not constraining it that the word boundary must be preceded by a punctuation, an end of sentence punctuation. So what this will do is it will split it into all the words. Then, so we will now take current words plus W. So the W is the well, so I need to see what this does. So if it's greater than target words, so essentially what you are doing is checking the size of the words, right? Um, so this is really to count, the W is to count the number of words in this sentence. Because after you split it into words, you take the length, right? So that gives you the number of words in this sentence. So you now increment the current words, which is tracking the total size of sentence of the total length of words in the sentences that we have chunked so far. So if the total number of words so far plus the length of this new sentence we want to add, if it is greater than our target, right? And there are already words in the, or there are already sentences, right? Which we're using CUR to track the sentences that you have, or the chunks that you have done so far. So if it is, then you will push a space, right? You basically push all of the sentences that you have chunked so far, or you have joined so far, because essentially CUR is tracking all of the sentences until the number reaches a target. Then once it reaches a target, which is the first part, it will join all those sentences into a single chunk, right? And push it into the chunks that we have, right? And then it will basically restart a new tracker. So essentially what it's doing is tracking through the sentences that you are taking and then counting it. So if the number of sentences you have so far exceeds, or if it is going to exceed when you add this new sentence, the number of words, the target words, then you will basically push the previous sentences you have collected into the chunk. You join them and push into the chunk and start a new set. That's what this does. But if it does not, then it means we can still add this sentence to the set that we are currently concatenating. So essentially what this does is just concatenating sentences and making sure that the length is not more than, the number of words is not more than the target words, right? Okay, so with that, at the end of the day, you still need to do a last chunking for the last word, the last set of sentences, and you add it to the chunk, so you return chunk. So this does a semantic chunking, breaking words and word at sentence boundaries, counting the words in the sentence, aggregating the sentences until the number of words in that aggregate of sentences is about to exceed the target word. If it's about to exceed, it does not continue adding. It will first of all push that one into a chunk and start a new chunk with the new sentence that you just came up with. That is what this piece of code does. So after that, then we are going to call the Hugging Face API and do embedding. So we are going to do embedding of the, we can do the entire paragraph embedding, which is much nicer than doing word embedding. So, so you will see this just calls the Hugging Face endpoint, right? And this is the endpoint for, let me see. So this is the endpoint that you use. Let's see, Hugging Face. All right. So we want to do an API call on an embedding model, right? And it's not a difficult thing. Models, sentence transformers. So let's look at their docs. So we have Hugging Face JS. So we can do this, right? Let's look for inference embedding. I see inference for let's see, we'll use API reference. Okay, so I think we can also do this by using the Hugging Face. Hugging Face actually has an SDK. So let me take this out. This is let's use the SDK. So to get the SDK, we can install it npm install Hugging Face inference. So that's the library that we see here. This library, not the hub, but the inference. So to use the inference client, we install npm install Hugging Face inference. So that's how we do that. So we are going to do that, and then we use that rather than trying to do an API call. It's easier to do it that way. So okay, so let's add it here. HF Hugging Face inference equals require Hugging Face inference. So we just installed it now, and then we require it, and we can take out, we have access to the HF inference instance, right? So then, yeah, we already have the Hugging Face API key here. So let's create a Hugging Face client. It will now be new HF inference. Even though that cross means it looks like it is deprecated. Oh, this is the old one. We have to specify the API key. So HF API key. Oh yeah. So inference client. All right. So inference client is the more modern way of doing it. HF inference is an older way. So they're recommending that. So you pass in the key, which we are going to put in our .env environment. Yeah. So with that, we have set that up. Now, to now do embedding, so I'm not going to do this API call anymore. Rather, to do embedding, we will just HF dot feature extraction. So feature extraction is how you feature extraction is how you do embeddings. No, it's so you specify the model. So we are going to use our model, and then the inputs would be the text that you want to. So remember our model from last time we were using so let's go back to sentence transformers. We were using all mini. So let's still go with all mini. right? So that's the model. We can also make this into a constant if we want, right? Okay. All right. So that is how we create the embedding. Then we don't need to do this. It's an API call, so just return embedding. I'm still going to test all of these functions later on. Okay. So now that we have done our semantic chunking, we've done our embedding. Let's go put in the endpoints. So I'm going to we'll start with a post app.post index upload dot array of files. So this is how we want to async. This is the endpoint. Response. This is a typical Node.js endpoint. Okay, so we have a try-catch block. We track chunks. Then we run a for loop on all the files that have been uploaded. So remember, the files have been uploaded. We need to read the contents of the files. And then we chunk it. So text, the read file. So we read the file. For each file that we get, we read the file. And we read it as UTF-8. And then we now chunk it. So we use our chunking method, semantic chunk. So we will pass in the text, which is text. Right. So target what we go with the default. We say, okay, 150. Maybe we can actually write it out explicitly. So let's just say 200. Then we now, so each of these chunks, we'll have to save it, right? So we first of all push it into the all chunks, this all chunks array that we created. And when we push it, we will also push metadata. So the text is the C, right? Which is the actual text in that chunk. Then we'll create a metadata item there, and we will put metadata. So like the source file where we got the chunk from, and then the actual part, like okay, the position or which chunk that we did, right? So that's it. Okay. Okay, so let's remove this. We still need a closing parenthesis. This needs to be removed. So what this does then is for each chunk that has been created here, we will just push the chunk in. I will push additional metadata. And this is very key. Then after this, we will delete the file simply because we don't want to keep the temporary files where the uploads were stored. It's like my thing is the way it's indenting is different from the way I want it to indent. So, but anyways, so that's the first thing. So after chunking, then we will do embedding, right? So embedding. So to do embedding, we have already created an embed function, which we'll just call. And since it's an API call, we have to await it. So in this case, we are embedding only the text, right? Which we have stored here. So the embedding will give us the list of vectors that match each of those texts, right? Then we can now save to FAISS index via the Python script. So we'll do payload path.join. So we have index here are meant to underscore index.json. Let me name like okay, so this is just a way of saving all the chunks, right? In this to index.json. Right. I remember the other time we had some kind of context which we can add here as well if we want. And use that. So let's do that. So let's add context. Context is also good for yeah, let's add a context. So I'm going to do that up here. Right. But get context. So we can generate a random context here. So what we did the last time was we used UUID. So so to use UUID, I would have to import the UUID library. So okay. All right. So we need to import the UUID. We can use crypto. well, okay, it's built-in nodes, so we can just use that. Uh, so we'll take the built-in crypto module and let's remove it. So let's use a built-in one. Okay, um, so where we use crypto, where we're using UUID to generate a random, we'll just use crypto, and then we'll use random UUID. Okay, and um, we can clean it up a little bit, clean it up, replace all the dashes, and then slice it, 0 to 8. So, so this allows us to have a context. If context is specified, we use that. If not, we use this. So the other thing we will do is in the metadata, we can also add the context here. So when we are searching, we can use that when we are searching. So the context, we can also use it uh, in the path as well. So to store this, so that different contexts will have different items going in there. Okay. So far what we have been doing is just the endpoint for uploading. And so we write this is the chunked file. We still need to write it to FAISS. So after doing this, we still need to write it. And the way to do that is um, we'll now call the Python script. So to do that, we will create a process, right, called Python. Of course, that's the Python process that's running. And then we'll invoke with this argument, the PyScript, which is a script index. Then we'll pass the payload or the file name rather. I call this index file and then index directory. So this will make meaning when we go to the other scripts to write it. I guess this still works. Okay. All right. So that's the section that does that. Then this is a try. So we'll catch if there is any error, we can just make a 500, right? And send the error. So this will help anyone that wants to debug to know what the problem is. All right, so that's the endpoint for uploading. Now, so the next thing is endpoint for query. So take note that we did a chunk and then we've passed that chunk, we've passed embedding, right, into there's something I forgot here. we need to add embedding. Yeah, so the chunks, remember we have created the chunks, right? And all chunks, we basically pushed a data structure here, an object that contains the text, right, as C, and then contains the metadata, right, as this metadata is now made up of the source file name, which of the what the nth number or the number of the chunk, right? And then the context, which we created here. So there's something I missed here, which is we need to add the embedding. So for each, so remember the all chunks will have we've created embeddings, right? And we basically want to now fit the embedding. So for each C, where C is the chunk, right? I is the index. We now want to add the embeddings. Okay. So we will assign, we're using the index because the index is important. Remember, we are creating the embeddings. This embedding is a list of embeddings that match the index numbers, match the text. So for each chunk, it has a text. You took the text, we embedded it, right, by calling the endpoint. And then when that comes back, we now go to the chunk and we update the embedding, right, which is going to be another one. So we have the text, we have metadata, and we have the embedding. All right. So we have completely set up all chunks, which is kind of the storage. And then we stringify it and store it in this index file, right? And then we now call the Python script. And the essence of calling the Python script is so that we'll run the script, we'll specify what it wants to do, which is index. There are two things, it's either indexing or it queries. So right now I want to call index. We pass a file that contains the JSON encoded value and then the index directory. So actually the index directory, this should be index directory and context. Okay. Yeah, one other thing I forgot. So if the spawning is successful, right? Or if it is not successful first, then if the start is not 0, that means it's not successful. Then we send the 500 again, right? And the error we will send will be okay. But if we get to this point, that means everything was successful. So we will send an okay, meaning that we were successful, and send a message as well, which is still going to come from the FAISS embedding script. So we send that. So this is our endpoint for uploading files, for chunking them, then saving them in the FAISS database. So note that if I was using Pinecone, for example, I will use a Pinecone SDK or use the API call. So I wouldn't have to do this Python script. But I just wanted to demonstrate how we can do that with JavaScript. So kill two birds with one stone. So now I'll do one last endpoint for us to query the, again, we'll query based on, right? So again, so the query first and then the K. So remember, we always do this K, which is the top K that you want to pull from your, oh yeah, let me put something else. So I could also do a C, right? Which is a context. If a context is not provided, maybe a context should be provided, but yeah, so let's say context is not provided. Okay. So we are taking 3 parameters from the request body, right? One would be the query itself. The second would be the top K matches, right? Which we can go with a default of 5. And then the third would be the context. So if there's no query, we'll send the validation error, right? So missing query. All right. So there's a whole bunch of other things, right, which we will do. Let me speed things up by bringing it in, and I'll explain the code. All right, so first of all, you start first by embedding the query. So you embed the query. We'll call the embed method, which already is Hugging Face. We're going to pass in the query as a list, like we did before. So we're going to get embedding. We extract it. It's a single one, so we extract it. And then we will then call the Python script that handles FAISS. And we're going to call the script. We are going to ask for query. This is the parameter. Then we will stringify and pass the embedding, pass the K, and pass the, so context should come as well, right? All right, so I was at the point where I was trying to set up the rest of the, let's see, congenial robot. Are there any questions while this is running? Let's hope that pass it on the Python one. So I still need to write the code on Python where I will effectively where I'll pull together the code that is going to access FAISS, and then yeah. So let's see. I was working on server.js. Okay, so in order to speed things up, I'll basically just bring the code in and try to explain it. So this is embedding FAISS. What this code does is to access FAISS, right? So we start off by, first of all, um, importing SysOS JSON, NumPy, and then FAISS. So FAISS is something that we install. So we have to install it here as well. So we have to. I think it's a good idea. I don't know if we should do this in a virtual environment, but let me just do that here. Pip. Okay, so probably didn't type that properly. Oh yeah, I think I've done that already. It's 5 CPU. I have done that already. Yeah, that has been installed already. So remember, if we go and check this server or JS, where we are calling files, we are calling files basically by calling a process, spawning library basically, and then we'll pass in the script location. Oh, sorry, the script location. We'll pass in what we want to do, index. We'll pass in the arguments for what we want to do, so index file and index directory. That's the first one. If we want to do a query, we pass in again the script file, and what we want to do is to query. Then we pass in some additional information. So here, yeah, we're trying to handle this context thing, which I was trying to figure out whether to do the context, whether to make it default to an empty string if it's not provided or not. So those are the things I was trying to decide. Okay, I hope I am being heard clearly. If not, let me know. So we have embedding, we have the number of elements. Let's add context. Let's just call it context. All right. So if it fails, we pass the error. If not, if it's successful, then we pass the return value, which is going to be a lot of information. And then what we now do is we take this context, the retrieved um, list of texts, right, that match that embedding that we pushed in. We will take it, and that's what this map does. Basically, it's going to create source is this, and then the path is this, then a new line, then the text, right? So it's going to put the actual text. It's going to join all of those, and then it takes that context and puts it into a prompt that says, use the following context to answer the question, right? So you put the context there, and then you put the question, which is the query that the user types in. So let me make this query. But let me make this question. And it's supposed to give you the answer. And with that, you call Gemini with that prompt. And the result from Gemini, you send it back. So that's as simple as that. Now we need to write the call Gemini function, right? Which uses Gemini library. So to call Gemini, let's do this. So in this case, we want to use Gemini. We've done this before, so we want to use Gemini. So first of all, we get the API key. Right. So if you look at this, we already have Gemini API key here. So I'll just use that.
So I don't need to do this already. I could do this something like if there is no Gemini API key, then you can throw me error and Gemini API key. Not set in .n. Okay, so that with that, then we now so in this case, let's use fetch. Let's see if I can get Gemini. Well, let's use fetch because I already have some code here. But I'm thinking whether to use endpoint or to use fetch. But that's okay. So if it is supply, we use that. If not, we use the Gemini's endpoint. So I think a couple of people have done this before. So yeah, this is that's the endpoint without specifying the model yet. So we're going to create the body. The body, this is just regular stuff we have been doing. So I need to go check and confirm this from their documentation. We can do temperature. We can do max output tokens. I don't like doing max output tokens though, because it just tends to, but let's make a pretty large value. So that is the payload we want to send. So we can now say response equals fetch. We now have model endpoint. I feel like I want to change this and use Gemini SDK. So let's do it in. Let's use SDKs. SDKs make things much easier for us. So it's better than calling APIs. Well, I did want to call APIs, but it looks like I don't have enough time basically for that. So okay. So Google Generative AI. how you do it. We already have the API key. We already have the API key up here. Yeah, we already had the API key up here. So what we now do is basically, yeah, I don't need the endpoint now because I just need to call it. All right, so we can add that in here. So right, so we require it. Then we will create a new instance. So along with when we are creating the new Hugging Face, so we can just gen AI for new Google generative AI. We'll pass the API key, sharing API key. So yeah, so we'll create our Gen AI. So it becomes much simpler. I don't have to be dealing with APIs. API is good to know, right? But now we need speed. So all right. So with that, I'll still maintain the body, even though I probably won't need all of it. So we can now do our response and see uh so we need to get a model, get generative. All right. We specify the model name. So I think we've been using Flash Pro, so Gemini 2.5 Flash. That's what we've been using. So then um, we just then run our prompt, right? And we can say, okay, equals await model dot generate content. And we use prompt. So it's as simple as that, and then we can return the result. Right. Now this is very simple. So if this error, it falls off. I don't need all of this. For now, let's just simplify things. So we create a new model, Gemini 2.5 Flash, and then we call generate content based on the prompt. And that's it. So with that, we are good. Remember that function we just created is what we will now call here a return. Okay, so this is our server, right? That does all of that. There are a bunch of other endpoints, right? But I'm not going to, like, if you want to look at context and everything, okay, so I'm not going to worry too much about those ones. Okay. Instead, I'm just going to set up and start the server. So to start the server, it's app listing. So that's how we normally start servers in Express. So yeah, so let me end it by listening. App.listen. We can take a port, maybe 3000. I could do that as an environment variable as well, but we don't have a lot of time. So we can now log anything we want. you can see JavaScript RAG server running on HTTP localhost 3000. Make it 8,000 or any other. Right. So we finished our server. So the last thing we need to do is we need to set this up. So this has been done already, but I'm just going to double check this. So mode is argv1. So normally this is a usage Python embeddings files, which is the name of the file. Just to confirm that that is being done properly as a script. Then you pass the query, the action, which is either index or query. If it is index, you pass the file that contains the index and then you pass the index directory. If it is a query, you pass the query JSON, which is effectively the embedding, the top 5, just information you need for the query, and then the context. And then you pass the index directory. So we'll look at how FAISS does this, right? So the first thing is, yeah, we take the mode. The mode is the first argument, v1, which is this. So it's either index or query. And then the index directory is v minus 1, which is the last argument. So the index file is going to be join the index directory FAISS.index, right? Then the meta file is going to be index directory meta.json. So FAISS uses index, you specify where the index file is, and specify where the meta file is. So if the mode is index, that means we want to put data into the vector database. So the payload is the second. In index mode, the payload is 012, which is this. And it's actually just the file name where you have serialized the payload and put it in there. So JSON load is going to first of all open that file name that you specify, right? And then it is going to load the content, which will be a string, a JSON encoded string. Then it's going to decode. So you have the data back. So that data is going to contain chunks. So if you look at what we did in the server when we were doing the index part of things, you remember that the index file, we actually stringified something and we gave it these chunks as the name. So when you retrieve chunks, you're going to retrieve all the chunks that were put in there, right? Or that were passed in there. So this is kind of a way of passing variables between two different processes. And this is one way of doing what we call interoperability between two different programming languages or processes. You store the file, you store the data that you want to pass to the other process, you store it externally in a file system, and then the other process will read it from that file system. Of course, remember to avoid what we call locking, the locking phenomenon. You need to close before you call. If you notice here, after writing the file, write file sync will make sure that the file is closed after writing to it so that this Python process can have access to it. So chunks contains the chunks. So what we now do is we take the chunks, right? We because it's JSON, Python is going to see it as a dictionary. So we pull the chunks. And then for each chunk, we take the embedding, which we had stored, right? As type is float 32, we convert it to float. First of all, of course, we load it into NP, a numpy array, because it's a vector, right? And then we convert it, we make sure it's float 32, which is a 32-bit point number. And then, so the dimension will be the shape 1, which is the width. In other words, the number of the size of the embedding, whether it's 384 or 768 or something. Then FAISS gives us, the FAISS library gives us what we call index flat L2, which is a flat index, right? So we will get a flat index, right? And specify the dimensions. And then that index that we got, we will add the embeddings to it. And then we will write it back to the index. So with FAISS, we are just essentially writing the embedding, right? We are not storing metadata. Well, okay, we have two places. We have one place where we store the embedding and the second place we store the metadata. So we store the embedding in this index. Then we need to still store the metadata. So the metadata is stored by creating, an object that contains all the metadata. So for example, here we have the text, right? We have the text, and then we have the actual text, we have the metadata. I'm going to add the context here because that's something I introduced. So I'm going to add the context. So the context, we will also see it as context. So I hope. So I'm going to double check that by seeing how did I write context in here. I wrote context as context. That's how it was passed into the chunk. So that means we'll also be able to access it at context because this C is each chunk. Okay, so we create the metadata. We then encode it into JSON and we dump it into the metadata file. So what this does is to ensure that we always have metadata. And then we print that we've indexed certain number of chunks. Note that we are kind of tracking the metadata file. So if we want to index additional stuff, we should be able to, add to what we already have, right? Rather than overwrite. So that's something I'm not checked, but we'll come back to that. Now, if the mode is query, so query means you will call you get the JSON query, which comes as a second argument, to this call, that is 012, that's this one. You are in the query mode, 012. So we take that query, and remember the query is also a JSON structure that contains additional stuff. So if you look at this where we have it as query, you saw it was a JSON.
Okay, let me see if I can round this up because we have really bad network here now. Let me see if I can round this up. So I'm going to share the code, but basically I think I kind of try to explain what the Python script does. So the FAISS library from Facebook allows you to run your own vector database on your own machine, basically, if you have the capability. And it uses very highly efficient vectorized, approach. It can even use GPU. So if you have GPUs, it can leverage on the GPU to make the index search much faster, right? Unfortunately, because of the network challenges, I was not able. I wanted to get this all done and then run it so we can see it. But I'll do it and I'll send everyone a link. So I would like to end it here because I think I'm already way past my time contract. So I'll stop the recording now. If there are any questions.